The Steducentre Grade 9 2013 A&A Exam Review Maths Part 4. Question 8.1. In triangle PRT below, M is the midpoint of PR and MR, which is equal to MT. If P is equal to 25 degrees, calculate with reasons the size of angle T1, the size of angle M2, and the size of angle R. It's important to know the rules when you're looking at a triangle. The interior angles of a triangle will always add up to 180 degrees. So A plus B plus C is equal to 180 degrees. The exterior angle of a triangle is equal to the sum of the two interior opposite angles. The exterior angle is obtained by extending one side of the triangle. So, in the second diagram, A is equal to B plus C. Equilateral triangles have all sides that are the same length and all angles equal to 60 degrees. So A is equal to 60 degrees and all angles are the same. Isosceles triangles have two sides of equal length and the base angles are equal. So A is equal to B. If we look at our triangle and we are told that P is equal to 25 degrees, we know that T1 will also equal to 25 because it is an isosceles triangle. We therefore know that the sum of a triangle is equal to 180 degrees, so you can work out M1, which is 130. If M1 is equal to 130, then M2 is equal to 50 because we have a straight line. Alternatively, you could say the exterior angle, which is P and T1, added together equal to M2. So 25 plus 25 is 50. We also know that we have another isosceles triangle. So that means that R and T2 are exactly the same. So you can say 180 degrees minus 50, which gives you your 130. You can then divide the two and you will end up with the 65. In 8.1.1, the size of T1 is 25 degrees because of the isosceles triangle. In 8.1.2, the size of M2 is equal to 50. And in 8.1.3, the size is 65 degrees because it is an isosceles triangle. In triangle ABC, D and E are points on BC such that BD is equal to EC and AD is equal to AE. 8.2.1, why is BE equal to CD? And 8.2.2, which triangle is congruent to triangle ABE? Because BD plus DE is equal to CE plus DE, we can therefore see that BE is equal to CD. And the triangles that are congruent is ACD is congruent to ABE because of side, angle, side. In the figure below, triangle KNQ and triangle MPQ have a common vertex Q. P is a point on KQ and N is a point on MQ. KQ is equal to MQ and PQ is equal to QN. You are asked to provide with reasons why triangle KNQ is congruent to triangle MPQ. There are a couple rules for congruency. For example, side, 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 or side included angle side, or angle, side, angle, or angle, angle, side, or your right angle, hypotenuse, and side. Side, side angle is not sufficient for congruency. It may make two different triangles. In KNQ and MOQ, Q is equal to Q because they are common. NQ is equal to PQ, that was given. KQ is equal to MQ, it was also given. So KNQ is congruent to MPQ because side included angle side is applicable. In triangle NML below, P and Q are points on the sides MN and LN respectively such that QP is parallel to LM. MN is equal to 16 centimeters QP is equal to 3 centimeters and LM is equal to 8 centimeters. Complete the following, giving reasons for the statements. Prove with reasons that the triangle QPN is similar to the triangle LMN. In triangle QPN and LMN, number 1, N is equal to what? Number 2, P1 is equal to what? Number 3, Q1 is equal to what? Therefore, your triangle QPN is similar to triangle what? And then you have 8.4.2. Hence, calculate the length of PN. Whenever you have parallel lines, you always need to remember fun. The F should show your corresponding angles. They are the same. Your U to show that the co-interior angles add up to 180 degrees. And your N to show that your alternate angles are equal. So for 8.4.1, we can see that angle N is equal to angle N. It's a common angle. We know that angle P1 is equal to M because we have corresponding angles and QP is parallel to LM. Number 3, angle Q1 is equal to L. We know this because we have corresponding angles where QP is parallel to LM. Therefore, QPN is similar to triangle LMN because of angle, angle, angle. 8.4.2. Here you have to calculate the size of PN. We also know that similar angles are proportionate. So QP over LM is equal to PN divided by MN, which is equal to QN divided by LN, which is same as 3 over 8, which is equal to PN divided by 16. So PN will equal to 6 centimeters. Question 9.1. Use the given grid to draw triangle A'(OB'), the reflection of triangle AOB in the x-axis. 9.2. Write down the coordinates of B', the image of B. 9.3. On the same grid, draw the rotation of triangle AOB through 180 degrees about the origin to form triangle A'(OB'). 9.4. Hence determine the length of A'. In geometry, a transformation is a way to change the position of a figure. So the transformations would be reflection, which is to flip, translation, which is to slide or move from one point to another, and rotation is to turn. Dilation is to make something smaller or bigger. You need to have the correct drawing for triangle A'(OB') and triangle A'(OB'). For 9.2, your coordinates of B' is 4 minus 2, close brackets. And when you determine the length of A', it will equal to 4 units. Question 10.1.1. Show that the area of the shaded ring is equal to pi capital letter R squared minus small letter r squared, close brackets. And 10.1.2. Determine the area of the shaded ring in terms of pi. If capital letter R is equal to 14 centimeters and your small letter r is equal to 8 centimeters. Question 10.1. The area and perimeter of a circle. A circle is defined by its diameter or radius. The perimeter or circumference of a circle is the distance around the outside. The area of a circle is the space inside it. The ratio of the circumference divided by the diameter is equal to pi. Pi is an irrational number whose value to 15 decimal places is 3.141592653589979, and we usually say pi is 3.14. The circumference is found using the formula C is equal to pi times d, or C is equal to 2 pi r, since d is equal to 2r. The area is found using the formula C is equal to pi r squared. 10.1.1. The area of the shaded ring is equal to pi, capital letter R squared, minus pi, small letter r squared. If you factorize and take pi out, you will end up with pi, capital R squared, minus small r squared. 10.1.2. The area of the shaded ring in terms of pi. If capital R is 14 centimeters and small r is 8 centimeters, it will equal to pi, brackets, 14 squared, close brackets, minus pi, open brackets, 8 squared, centimeters squared. And if you do the sum, you end up with 132 pi centimeters squared. 10.2. In the triangular prism below, triangle PQT is congruent to triangle PRT. PQ is equal to PR and PT is perpendicular to QR. 10.2.1. Determine the length of QT if QR is equal to 48 centimeters. Give a reason for your answer. 10.22. If PQ is equal to PR, which is equal to 25 centimeters, show that PT is equal to 7 centimeters. And 10.2.3, hence calculate the area of triangle PQR. The Pythagoras theorem. Pythagoras was believed to be the first person to prove that this rule worked. In a right angle, the sum of the squares of the legs is equal to the square of the hypotenuse. If you look at the angle, you'll see that you have the opposite and the adjacent, and then the hypotenuse line, which is the longest. You need to look at the angle, which is the red line. The angle adjacent to it will be the one next to it, and the one opposite will be one on the opposite side. So Pythagoras will say a squared plus b squared is equal to c squared. If you are looking for area, it will equal to half base times height. So for question 10.2.1, QT is equal to TR, which is equal to 24 centimeters. Therefore, PQT is congruent to PRT. In triangle PQT, PT squared is equal to 25 squared minus 24 squared in terms of centimeters, if we're looking at Pythagoras, which is equal to 625 minus 576 centimeters squared, which is equal to 49 centimeters squared. And if you find the square root of that, PT will equal to 7 centimeters. The area of PQR is going to be 48 times 7 divided by 2, which is equal to 168 centimeters squared. 10.2.4. Calculate the volume of the prism if RS is equal to 80 centimeters. And 10.2.5. Calculate the surface area of the prism. If you're looking for the total surface area of a triangular prism, you need to be able to open it up and see that it is made up of 3 rectangles and 2 triangles. The 2 rectangles are the same and the one might be different. If you are looking for the volume of the prisms, these are the formulas that you will use. Volume is equal to length times width times height when I am looking at my rectangular prism. Volume is equal to half times base times height times height. And for a cylinder, volume is equal to pi times r times height. So volume is equal to pi r squared times height. So the volume of the prism, if RS is 80 centimeters, is going to be area of the base times height, 168 centimeters squared times 80 centimeters, which is equal to 13,440 centimeters cubed. If you have to calculate the surface area of the prism, it's equal to 2 the area of PQR plus 2 of the area of PRSW plus area of QRSU, which is equal to 2 times 168 centimeters squared plus 2 times 80 times 50 centimeters squared plus 80 times 48, which will give you 336 centimeters squared plus 4,000 centimeters squared plus 3,840 centimeters squared, which is equal to 8,179 centimeters squared. Thank you for watching the Steducentre, turning ordinary learners into extraordinary leaders.